Saturn's rings are one of the solar system's most spectacular sights, with them essentially being synonymous with Saturn's identity. Take the rings out of the picture, and you barely even recognize it. But what exactly are these rings? How did they come to be? And is Saturn unique in possessing these kinds of rings? Now, before we get into outer space's version of jewelry, I'd appreciate you to like the video, subscribe to the channel, and hit the notification bell to stay tuned for future content. Okay, so how did Saturn get its rings to begin with? Well, there are a few ideas, but the most likely theory is that it happened when an ancient moon of Saturn got too close to the planet and disintegrated. You see, in order for an object as large as a moon to stay stable, that object needs to orbit relatively far away from the planet. If a moon strays too close, it can easily get torn apart by intense tidal forces. Or put another way, the imbalance in how strong the planet's gravity is between the near side and far side of the moon is so massive that the moon physically cannot hold itself together. For a planet as massive as Saturn, this happens a few tens of thousands of miles from the surface. When the moon gets torn apart, different parts of the moon will travel at different speeds due to the stark differences in tidal forces, and eventually, these particles will spread out and travel around the planet, forming a ring system. According to this theory, Saturn likely gained its rings about 100 million years ago, when a moon several hundred miles wide either drifted too close and broke apart, or potentially got destroyed by another large object smashing into it. Due to Saturn's gravity, little bits and pieces of the rings constantly rain on Saturn, causing the rings themselves to slowly shrink over time. As a result, it is estimated that the rings will remain in some way, shape, or form for another few hundred million years, gradually shrinking until there's nothing left. At that point, only time will tell whether or not Saturn will regain its rings in some way, shape, or form at any point in the rest of the solar system's lifespan. Okay, so enough about the rings, how the rings came to be. What exactly are the rings themselves? Well, they are composed of billions of tiny particles of ice and rock, with some particles being no bigger than a literal grain of salt and others being the size of a house. For how much they stand out, the rings themselves are extremely thin. Some parts of the rings are as little as 30 feet or 10 meters thick, an incredibly tiny distance when you consider that they go around a gas giant. One thing to note is that the rings are not one uniform structure, but are rather composed of several different rings with gaps in between them. The largest and brightest of these rings is the so-called B ring, which spans over 10,000 miles across and reflects over 90% of the light that hits it. Several smaller rings exist, most notably the A and C rings, which are the outermost and innermost of the main rings respectively. But why are there separate rings to begin with? Well, there are several major gaps in the rings themselves, with the density of those particles of rock and ice decreasing dramatically in these regions. For two of these gaps, there is a moon that is orbiting within it, and the gravity of these moons is enough to clear out any particles in that region. Several other gaps exist in interesting locations where the gravitational influence of other moons is able to clear out that area, despite being located far beyond the rings themselves. This is due to some complicated orbital mechanics that I can't really get into here. But what essentially happens is that an object orbiting in these locations will, at a certain point in its orbit, get a speed boost that changes the orbit as a whole, ultimately putting the object outside of that region. This process has cleared out several regions in the rings, and has created the majority of the gaps that we know of. There are a handful of small gaps that we do not know the cause of, as there are no known moons orbiting in them, and they are not in locations where other moons can give an object in the gap enough speed to exit it. In general, the structure of the rings themselves is surprisingly complex not only due to the gaps, but simply due to how material tends to clump in some areas while being a bit sparser in others, which causes the brightness of the rings to vary considerably. Okay, so we know Saturn has rings, but do any other planets have rings, or are they a uniquely Saturnian phenomenon? Well, not only is Saturn not the only planet to have rings in our solar system, but every single one of the gas giants has a ring system in some way. The ring systems of the other gas giants are way older and dustier, so they aren't bright and colorful in the same way as the rings of Saturn. In particular, the ring systems of Jupiter and Neptune are so faint that it took until the late 20th century for advanced technology and spacecraft to confirm that they actually exist. None of the inner rocky planets have rings of their own right now, which is likely a testament to the fact that it's difficult to have a natural satellite orbiting a planet when it's so close to the Sun, as well as other planets like it. However, this may not be the case for much longer. You see, one of the Martian moons, Phobos, is slowly spiraling towards the planet at the rate of a handful of centimeters per year. Since it already orbits fairly close to Mars, it is estimated that in about 30 to 50 million years, it will reach the point where tidal forces are stronger than its own gravity, which will cause it to break up. Phobos is a very small moon, being only slightly bigger than the asteroid that is theorized to have killed off the dinosaurs. But since Mars is such a small planet, the breakup will likely give Mars a spectacular ring system of its own, which will likely last for a few million years. In a similar fashion, Neptune may also gain a more robust ring system of its own, as its largest moon, Triton, is also very slowly deorbiting into the planet. However, this is predicted to take significantly longer, with current predictions showing it breaking apart into a ring system around 3.5 billion years from now, at which point there probably won't be life on Earth to see it. But our solar system is not alone in producing planets with rings, and in fact, if observations of a different distant exoplanet are to be believed, Saturn's rings are not even close to the biggest out there. In 2007, astronomers discovered that a young sun-like star about 450 light-years away was undergoing significant fluctuations in brightness, with the fluctuations lasting for almost 2 months. This was attributed to a brown dwarf with an absolutely enormous ring system, one with a radius that is a staggering 60% of the distance between the Earth and Sun, which is over 1,000 times the radius of Saturn's rings. Given how young the system is, it is highly likely that this is a sort of protoplanetary debris field that will coalesce into asteroids, planets, and moons in the future, but the fact that this ring system exists at all is still nothing short of incredible, and it just goes to show what's possible in the universe. And that's all I have to say about planetary rings. As always, I'd appreciate like your video, subscribe to the channel, and hit the notification bell to stay tuned for future content. Thanks and have a great day.